And welcome to Naughty Notes. Well, we're going to look at a pair of theorems. Let's start by having a look at this one, which is going to relate chords and arcs. So, as you can see from the text here, this could involve one circle, let's say the red and the blue, or it could involve congruent circles. Let's suppose it's like that. Now, this is just to visualize. Let's say I took this. Remember, they could overlap. So the figure could look like this. Might be a little harder to see if they overlap. But if I were to do this, I can really see the congruence there if I just put them one on top of the other. And that's just to visualize. So we're going to imagine that. Or again, if it's congruent circles, if the arcs are congruent, so are the chords, and vice versa. All right, well that's okay. But let's have a look at, now I guess it's time to pull out the compasses and give them a swing. Okay, we're starting with this one. This is our theorem 10.3, going to relate those chords and arcs. So we're going to start this time. I gave you just 2 points. I may have given you this point, I can't remember, but see what your worksheet says. But if I didn't give it, just pick a random point A down there somewhere. And we're going to pull out our compass and we're going to gap it from B to A. Pretty easy, right? And then we're going to pick up our compass and we're going to transfer that distance. Give it a swing right there. And of course, where that intersects is going to be my point E. Now you know you've just made a pair of congruent segments, which happen to be chords because they are on that same circle. And because you use the compass to transfer distance. So now, from the center, take your straight edge, and you could draw. Now, you could draw these radii, and we know that they're all congruent. You can draw rays or segments. I'm okay either way. But you know you've got something going on there, and something's jumping out at you all the way back to first semester. Heavens to Murgatroyds, you're going to say, you've got 2 congruent triangles by side, side, side. And now you say, well, okay, I've got those 2 congruent triangles. So what does that mean? Well, CPCTC tells me that I've got these angles, or those 2 angles are congruent, ACB, and the angle ECD, or DCE, either way. And since you've got those 2 angles congruent, I can then say the congruent angles, we know that means their intercepted arcs are congruent. Wow. So that means I can fill in the blank up here. Their corresponding chords are congruent. Hey, that's kind of fun. So what do we know after all? In this particular example, AB is congruent to DE, the arcs, if and only if their associated chords are congruent. If and only if, because it is a biconditional statement. So saves us writing a theorem, doesn't it? Works both ways. Now, let's construct another one. Ready? Okay. Talk me into it. I'm going to take a random chord, TR. I've got a circle here with a random chord. And now I'm going to pull out my compass and I'm going back to my very first construction. And gosh, you guys remember this one because how many times have we done this? And we like to do it in the classic way, even though in that with a collapsible compass, whenever we can. You're going to put the needle on R, gap it to T, and then reverse it, needle on T, gap it back to R. And what do you get? Well, you get the 2 points of intersection, and therefore, you get the perpendicular bisector. You get that perpendicular bisector. We'll put the marks in there to show me that it's a perpendicular bisector. Right there, you've got the tick marks for bisector, and you've got the little right angle there for perpendicular. Now, this is a line. This is if I take this line, and I'm just going to put in some points on the intersections there. I'll say it intersects at SQ. And, well, that means that segment is also a chord, and that chord happens to go through the center of the circle because that is a diameter. And now we can fill in the blanks. Okay, well